So for this conversion, you want to convert 2 meters into millimeters. So this is the conversion factor right here. No need to open up the table and look at it because they already have it set up. So what you have to think about is, since there is an equal sign in the middle, you want meters to be equivalent to meters. So how do you start off with 1 meter and end up with 2 meters? 1 meter 2 times is going to give you 2 meters. So you have to multiply by 2. Whatever you do to the denominator, you have to do the same thing to the numerator, and you'll have your answer. It's that simple. So let's go ahead and put these numbers in. So 1 meter 2 times is going to give us 2 meters. And since we multiplied the denominator by 2, we need to multiply the numerator by 2. Now for our numerator, we have 1,000 millimeters. 2 times is going to give us 2,000 millimeters. So since when our denominator is equivalent to 2 meters, so we can say for every 2 meters, there are 2,000 meters. So in this case, our numerator is our answer. Let's look at another one. That one was really easy. Here's another one right here. How do you start off with 1,000 milliliters and make it equivalent to, because that's what the equal sign means, 4,000 milliliters? 1,000 4 times will give you 4,000. So if you multiply the denominator by 4, you have to multiply the numerator by 4. 1 liter times 4 will give you 4. So that means 4,000 milliliters is equivalent to 4 liters. This is using dimensional analysis, so this is a different method. This method, you really want to know how to multiply and divide fractions. So we want to convert 6,000 milliliters into liters. So I do need to get my conversion table, so I'm going to open that up right here, and I'm going to move it to the side. So I need the conversion to go between milliliters and liters. So if I look at my conversion table, I see milliliters right here and liters here. So the conversion that I need is, for every 1,000 milliliters, there is 1 liter. And you actually need to know this one by heart for your LEAP test because it will not be provided. So we want to put 1,000 with milliliters, and we want to put the number 1 with liters. Make sure you do not put the wrong number with the correct unit. So since we have milliliters in a numerator, we want milliliters to cancel out, so we have it in the denominator here. But we have to decide, do we put 1,000 with milliliters or do we put 1 with milliliters? So we definitely want to put 1,000 with milliliters because that's the number that's in front of it in our conversion table. So I'm going to come over here and I'm going to put 1,000. So when the denominator is 1,000, the numerator is going to be 1, because for every 1,000 milliliters there is 1 liter. If you mix these up, you will definitely get the wrong answer. If you put 1,000 milliliters in a numerator, you will have the wrong answer because the 1,000 is with the milliliters and not with the liters. So if you put 1,000 with the liters, you will definitely have the wrong answer. You need to put the 1,000 with the milliliters and set it equivalent to 1 liter, which is what I have here. Now you have to remember, how do you multiply fractions? So since 6,000 is a whole number, put this over 1 so you don't make a mistake and multiply that with your numerator and your denominator. Now, how do you multiply fractions? So you have to multiply your numerator times your numerator. So we have 6,000 times 1 liter. This canceled out. So in our numerator, 6,000 times 1 is going to give us 6,000. So I'm going to put 6,000 right here. And then for our denominator, we have to multiply our denominator across. So we have 1 times 1,000. And that's going to give us 1,000. And now, since a fraction is a form of division, we have 6,000 divided by 1,000. And since I know decimals work with the numbers work with the power of 10, and I'm dividing by 1,000, I can take that decimal point in 6,000 and move it 1, 2, 3 times to the left, 1, 2, 3 times, and my answer is 6. Another thing you could do is just cross off your zero. So if you have zero in the numerator and denominator, you can cancel them out like this, and then you have 6 divided by 1. And 6 divided by 1 is 6. So we can say 6,000 milliliters equal to 6 liters. And that's that right there. So that's what you have to do on your test. The next one, let's get our conversion table. So we want to convert DAG, which is deciliters, into grams. Deciliters, DAG into grams. So the conversion factor that you need is right here. And then we have to set it up, which you don't even need to open it up here, because it's telling you that you have to multiply by 10. The only way that you multiply 3 7/10 by 10 is if you have a 10 right here. So this right here is telling me that I need to put a 10 right here and a 1 in the denominator, since I didn't have to multiply anything in the denominator. But my conversion will tell me that as well. I need to put 1 with the deciliters, and I need to put 10 with grams. So I'm going to put 1 with the deciliters and 10 with the grams, which doesn't surprise me because I'm multiplying 3 7/10 by 10, which is this right here, 3 7/10 over 1 times 10. So I know I was going to have to do that anyway. Now look at this. Since I have deciliters in a numerator and deciliters in a denominator, it will cancel out because its value equals 1. And then when I multiply across my numerator, I have 3 7/10 times 10 grams. So 3 7/10 times 10, since I'm multiplying by the power of 10, I can move my decimal point one time, since 10 have 1 0, one time to the right. So since I'm multiplying, I want to move my decimal to the right. I want my number to get larger. Dividing by a power of 10, you want to move it to the left, because your number should get smaller. But anyway, so now instead of 3.7, our decimal point is behind the 7. So our final answer is going to be 37. So I'm going to put 37 right here. So when we convert 3 7/10 decograms, it's going to be equivalent to 37 grams. Here is another one that you have to know by heart. So cm is centimeter. So we've been working with percent. We've been working with cent. So you need to know what cm means. So we should know that for 100 centimeters, centimeters is 100 is equivalent to 1 meter. You have to know this one by heart for your elite test. Cent, remember that root word cent, so you should be able to remember this one. So I want to convert 20 centimeters into meters. So I'm going to start off, I'm going to use dimensional analysis. I'm going to put 20 centimeters. And since I'm starting with just 20 centimeters, I'm going to put this over 1. And then I'm going to multiply by my conversion factor. So since I have centimeters in a numerator, if I want centimeters to cancel out because I have multiplication in the middle, I need centimeters to go in the denominator, because centimeters divided by centimeters equals 1. So I'm going to set this up, and I'm going to put centimeters in my denominator, 100 centimeters here. And then since this is my rate, if I put 100 centimeters in the denominator, it's equivalent to every 1 meter. So I'm going to put 1 meter in the numerator, because for every 1 meter there is 100 centimeters. So this is our conversion factor that we're using to get our centimeters to cancel out. How do we get our centimeters to cancel out? Because we have centimeters in the numerator and centimeters in the denominator. Now I can just multiply across. 20 times 1 meter is going to be 20 meters for my numerator, and then 1 times 100 is 100 for my denominator. Now I can divide. So I have 20 and I'm dividing by 100, so I can move my decimal point 2 times to the left, and that's going to give me 0 and 2/10 meters. That 0 is just the placeholder. So I can cross off that 0 and look at that, 2/10. So literally that's my answer, 2/10 meters. Look at this one right here. You will definitely see this question. So a restaurant chef at a restaurant uses 19 pounds of butter each day. About how many grams of butter does the chef use each day? Use the conversion factor, 16 ounces for every 1 pound and 28 and 4 tenths grams for every ounce. The chef uses about blank grams per butter each day. It says round to the nearest gram. That means we need to round to the nearest whole number, or you will get this question marked wrong. Round to the nearest whole number. The nearest whole number is going to be the nearest gram, so keep that in mind. So we want to have a plan. Our plan is to convert 19 pounds into, it says grams. So I'm going to start with what I want to convert. So I want to convert 19 pounds. And I'm going to put some space because I don't want this L to look like a 1. I'm going to put this over the number 1. And then I'm going to multiply by one of my conversion factors. Now, since I want to start with pounds and convert it into grams, I need pounds to cancel out first. So if I look to see which conversion factor I need, it's going to be this one right here. So since I have pounds in the numerator, I need to put pounds in the denominator. So the part of my rate that's pounds is going to be for every 1 pound. So I'm going to put 1 pound in the denominator. There are 16 ounces. So that's going to go in the numerator. So this is going to get pounds to cancel out. So pounds and pounds will cancel out. I need to convert again using another consistent rate. So this is going to be my conversion factor. So since I have ounces in the numerator, I need it to cancel out because I have multiplication in the middle. So I'm going to put ounces in the denominator. So for every 1 ounce, so I'm going to put 1 here, there are 28 and 4 tenths grams. So this part is going to go in my numerator. Now that I have ounces in the numerator and ounces in the denominator, it cancels out because its value equals 1. Now I can multiply across. So we have 19 times 16, which is going to give me 304. So we can say that 19 pounds is equivalent to 304 ounces, but we need our final answer in grams. So we need to take that 304 and multiply by 28 and 4 tenths. And that's going to give us 8,633 and 6 tenths. And since we only have grams left, that's going to be our units left in the numerator. For our denominator, we have 1 times 1 times 1, and that's going to be 1. And then this, any number divided by 1 is itself. Now the final answer says round to the nearest gram. So I need to round to the nearest whole number. So I need to look at the tenths place, which is the 6. And since 6 is 5 or more, I need to go up with the ones place. So my final answer is going to be 8,634 grams. So we can conclude that all of these are equivalent if we use our conversion factors. So remember, let's look what's going to happen on your test if you put that, if you don't round to the nearest gram. Here you go right here. This is what will happen. Incorrect. So what you want to do is make sure you round to the nearest gram, and then you'll get the answer correct. All right, let's look at this one right here. So we want to convert. So a school custodian discovered a leak in a water pipe. The custodian found that 1,920 fluid ounces of water had leaked out. How many gallons of water is this? Use the conversion factor. 1 gallon is equivalent to 128 fluid ounces. So we want to convert. Our plan is to convert. You always want to know what you're starting with and where you're going. 1,920 fluid ounces into gallons. All right, so what am I starting with? What am I starting with is my plan to convert 1,920 ounces. So this is what I'm starting with right here. And I'm using dimensional analysis. 1,000, you can use whatever method you like though. And I'm gonna make sure I put fluid ounces so I don't think that the O is a 0. I'm gonna start with 1,920 ounces over 1, and then I'm gonna multiply by my conversion factor. Now since I have fluid ounces in the numerator, I want to put fluid ounces in the denominator because I want it to cancel out. I have multiplication in the middle and not an equal sign. If I had an equal sign in the middle, then I will put fluid ounces is equivalent to fluid ounces, but since I have multiplication, I want my units to cancel out. So I'm going to put 128 in the denominator, 128 fluid ounces. For every 128 fluid ounces, there is 1 gallon. So now that I have fluid ounces in the numerator and fluid ounces in the denominator, is going to cancel out, and I'll be left with my final answer with grams in the numerator. So now I'm going to multiply across. I have 1,920 times 1 gram. That's going to give me 1,920 grams. I'm going to put that fraction line, and I have to multiply my denominator across. 128. 1 times 128, which is 128. Now my final step is to divide, because a fraction is a form of division. So I have 1,920 divided by 128. Let's do that over here. 1,920 divided by 128. 128 goes into 192 one whole time. 1 times 28, 128. I'm going to regroup here. Bring my 0 down. Now since this end with a 0, I'm going to try 128 times 5. Crossed off this 8 and I crossed off the 0. And I asked myself, how many times does 12 go into 64? So I know that that's 5 times. So you have to know that. You can cross off another number, but that'll be too much. So the first number I'm going to try is 128 times 5. So that's going to give me 40. 10 plus 4 is 14. 5 plus 1 is 5 plus 1 is 6. So right on, I get 15. 15 times 128 is 640, and it terminates. So we can conclude that 1,920 fluid ounces is equivalent to 15 grams. This is our final, or 15 gallons. G is gallons. And that's how you do that one. So basically, if you use the conversion factor method, you just want to set up your units, get it to cancel out, and you have to know how to multiply and divide fractions. This is a conversion that you definitely need to know how to do. You need to know this conversion on your own. It's on Pearson, but you have to know that 3 feet is equivalent to 1 yard. And you have to know that how many yards are in a feet, how many inches are in a yard. You have to know the conversions, which are in your guided notebook. I have to get the page number. So we want to convert 13 yards. You always have a plan. We want to convert 13 yards into feet. Now you can use equivalent ratios here. I'm going to use dimensional analysis. I'm going to start with 13 yards. Now I'm going to put that over 1. I'm going to multiply by my conversion factor. So since I have yards in the numerator, I'm going to put yards in the denominator. So here's my rate right here that I'm going to use to convert, to change. So I need to put 1 yard in the denominator because I want yards to cancel out. So since I have yards in the numerator, I need yards in the denominator because yards divided by yards equals 1. So it'll cancel out. So for every 1 yard, there are 3 feet. So I'm going to put 3 feet in the numerator. So now that I have yards in the numerator and yards in the denominator, it cancels out, and I'm going to multiply across. 13 times 3, or 13 3 times, is going to give me 39, and I have feet. For my denominator, I have 1 times 1, which is 1, so I'm not going to bring that over. So my final answer, 13 yards, is equivalent to 39 feet.